So we are looking at module one on data science and business analytics foundation, and I'm expecting that to see contributions from you team members. And in case you have any question, any point that you need to be clarified, just feel free to interject. You can raise up your hand. You can send a chat message and so on. So as we said also that the first unit is theoretical, just for the purpose of giving you a general overview about data science, business analytics, artificial intelligence, and any other related disciplines such as data analytics. And that one will guide you moving forward on what you are doing, or what actually you are doing, or the objective of the certification that you are doing. So I just want us to start by defining what data science is, and I'll give my definition, but also I'll be looking forward to hear from you because I'm very sure you have also done your own research, and I don't want you to Google, but I just want you will give me like your opinion of what you heard about data science and so on. So when we are talking about this term data science, I think it has been a jargon, and many people do not really understand what it is. And when we come to the African market, for instance, this is still a very gray area. And as I have been looking even for other organizations when they are doing recruiting, when you look at the JD, sometimes they cannot really differentiate between various disciplines in data science and so on. So, so when we are looking about this data science, and according to a lot of publications, ethical and so on, the definition sometimes is being misguided with an assumption that it is universally understood. And one challenge that I can say about this is not like when we look at biological terms, they have a special way in which a standardized way in which they rename, like when you are talking about COVID-19 and so on, and the name is being accepted globally. So, but let us look at what data science is. When we are talking about data science, you are talking about the methods, you are talking about goals, and you are talking about applications. And these applications evolve with time and technology. So, why do we say that these methods, goals, and applications evolve with time and technology? 25 years ago, when we are talking about data science, it referred to gathering and cleaning data set, then applying statistical methods to that data. That was still data science, but mostly, in case we have anyone in this class who has done a course in statistics, mathematics, and so on, basically what those people used to do during that time is what we call data science that time, though the name had not come out properly. And the main reasons, one, is that when you look at the adoption of technology, I think between 2005 onwards, that's where now most people started getting gadgets, that's mobile phones and so on. And of course, the when we look at the penetration maybe of the smartphone and so on, maybe we can talk about 2010 there. And nowadays, anyone can afford a smartphone. So with that, what it means is that there's a lot of data that is being now generated, and a lot of things have to change in terms of the tools that we use to analyze the data, among many other. So coming now to 2018 going forward to date, and this field called data science has really grown. 2018 to today is about 4 years, and the field has really evolved. And when you are talking nowadays about data science, it involves data analysis. It involves predictive analytics. Predictive analytics, you are trying to use your data to forecast, to look at what will happen in the future. We have data mining. We have what called business intelligence. You are going to look all of them one by one. Machine learning, deep learning, and so much more. So we see that when you are talking about data science, it's a very wide field. It is not like how it used to be 25 years ago. That's before 2018. So basically, it is a field that covers a lot of areas. And we can also see that it depends with the organization. An organization, and that one we will look at it later. Organizations that have a lot of budgets, they can they can hire someone who just does data analysis. They can hire someone who just does predictive modeling and so on. But others, you can be hired as a full stack data scientist, meaning that you are able to perform data analysis, you are able to perform predictive analytics, you are able to do data mining, business intelligence, machine learning, deep learning, and much more. Before now we go to different concepts, I will also like to hear from you guys what he knew about data science before maybe today's class. Anyone who wants to attempt, you can just raise up your hand. Anyone who did any kind of research before the definition that you have said that data science has grown to a field that encompasses data analysis, predictive analytics, data mining, business intelligence, machine learning, among much like other concepts. Anyone who has ever tried to do research, we are all learning, so always feel free to interact. Yes, Vincent.
Science is interdisciplinary academic field that deals with statistics and algorithms.
You are not audible. I think you are far away from your mic.
Data science is an interdisciplinary academic field that deals with algorithms and statistics.
Okay, thank you. So, based on what you knew, it deals with algorithms and statistics. And that one
Yeah.
mostly is, yes, Vincent?
No, I was just saying.
Okay, thank you. So when we are talking about the definition that Vincent has given us, that basically is just machine learning mostly alone. When we are talking so much about algorithms and so on, so that one basically we can talk about so much in machine learning as compared to data science. Even from the name, a science is a very wide field and so on. So, having defined that, we now have to look at what we call data. Yes, Jesse?
According to what I know, the definition of data science is the process of extracting knowledge and insight from data using specific methods.
Yeah, I think your definition is more clear because when you are talking about extracting knowledge from data using specific methods, you can we can talk about predictive methods, we can talk about data analysis, machine learning, and so on. Thank you so much, Jesse, for that definition as well. Maybe we can proceed now. In case you have a question, you just raise up your hand. I want us now to look at what you call data. I want us to look at what you call data. So when we are talking about traditional, data, we can talk about traditional data and also what you call big data or what you call or modern kind of data. So I want us to start by looking at what you call traditional data. So when we are talking about traditional data, I can say that this is the foundation of data science and all like it is the basis in which all the analysis are based on. So we normally have what called a traditional and big data. And when we are talking about this traditional data, in fact, even currently in most of our organizations, I'm sure most of you, even those in the business intelligence departments and data departments, about 90% confident that most of us you are using traditional data as compared to modern data. Let me check. I think there's a message somewhere. A bit low. Okay. I see Jesse wants to take me to an English class, but I think when you are talking about data in general, you are talking about a collection of information. So I don't know if there is, I haven't had data in singular or plural, but maybe I have to revisit my English class and know if there is data in plural or singular. But for now, let us proceed anyway. When we are talking about data, we have what called the traditional data and the big data. And traditional data, in most cases, is structured. And I just want to give you an example of a structured data. This data is structured and stored in databases. I'll try to explain each aspect that I feel that it is complex. What do we mean by structured? Currently, as you are being admitted at Afri CGSA, I'm sure the operations person was asking about your details, mostly the contact details, name, ID number, phone number, IBEC admission number, among many other information maybe that they were requesting from you. You see, all that data in this class, I'm aware that you are supposed to be about 22 students. You see, all that data can be input in an Excel format. And when it is input in an Excel format, then we can call that as structured kind of data. And that structured kind of data mostly is stored in what called databases. in various companies and so on. And this data is in a table format, and in most cases contains numeric and text values. Let me just try to share something so that we enhance understanding here. Let me open an Excel sheet so that like I can try to explain further. Let me try to open an Excel workbook and share my screen here. So this is structured data. Maybe let us say this is the serial number. Then name, maybe phone number, maybe admission, IBEC, admission number, and so on. So we have maybe say 1, 2, 3, 4, 5. Let us say these are our students. We are having Vincent. We are having Jesse. We are having Cyprian. Then we are having Dennis. Then we are having Rosebell. After that, maybe you are having phone numbers there. Let me say this is 001, 002. I'm just using to demonstrate. Sorry. Sorry. Okay, then maybe we are having IBEC admission number. I'm just using this to demonstrate, because we don't want to assume that each one of us knows how to So let me just go back now and explain whatever I was trying. So when we are defining traditional data, we say that this data is structured. That's the first thing. And whatever you can see from my screen that I have shared, this is what we call structured data. The second thing, we say that it is stored in databases. We have various kind of databases. We have what we call relational databases, such as what we call the SQL servers. We can have the MS Access database, the one that I think that we all have come across, if I'm not wrong, the Microsoft Access, and any other kind of database that you can store your data in. Another thing we said about structured data is that this data can be managed from one computer, and also it is in table format containing numeric of text values. So, as you are saying that it contains both numerical and text values, when we look at column B, the name column, you see it is containing what you call text values. When we look at the four numbers, it is containing numerical values. So this is what you call traditional data. And that's why I said I'm very sure most of you, this is the kind of data that you are dealing with in your organizations. Let me go back now to my presentation. Just a minute. Okay. So we have looked at traditional data. Now let us talk about big data. I think this big data is what everyone is talking about. Everyone is talking about big data, big data. It has been something that each person wants to hear and so on. So when we are talking about big data, and a lot of the data currently is big data, about 95%, if I'm not wrong. We are talking about extremely large data, and this data is distributed across a network of computers. And as we have said that it is big, it doesn't mean that when it is big, it is characterized by the volume alone. It means that this data can be various formats. It can be structured. So you see, we have big data that is structured as well, but we have big data that is semi-structured and unstructured. Since I have explained structured, let me explain more on unstructured kind of data. On semi-structured, on semi-structured also I'm going to explain. But let me start from the unstructured kind of data. Currently, as we are talking about, a lot of data is being generated in various platforms such as social media, mostly social media platform, internet, and so on. So let me pick social media platforms. In social media platforms, this data that is being shared mostly is unstructured. We have voice notes that people are posting. We have images that people are posting. What else? We have text that people are posting. All that is unstructured kind of data. And how do you analyze text data, for instance, to make business decisions? And that one, when you reach a certain topic in machine learning, we have what's called natural language processing. Let me say, maybe a certain telco, maybe MTN, has a social media platform, maybe Twitter and any other. So when they are posting, as part of their marketing strategy, that digital marketing strategy, people will always be commenting. And therefore, as the marketing department of this company, how are we going to harness and analyze that data to know, based on our posts maybe that we have been doing during the month of April 2023, which one has led to more positive reactions, which one has led to more negative reactions, and which one has led to maybe more neutral reactions. And then with regards to that, the marketing department is able to make a decision on how to align the content, the marketing content, with maybe what customers want to hear and so on. So you see that that data is generated in form of text data, but through what you call natural language processing, which you will learn in machine learning, you are able to analyze that text data and get insights. So that text data also is part of this big data, unstructured data, the same as reviews that customers are giving us in various, what can I say, platforms and so on. All that is unstructured kind of data. And also, semi-structured, let me give an example of semi-structured data. We do have what called metadata, if you have ever heard of metadata. Metadata is data on, like data on data. Let me just use that term. For instance, let me give an example. When you are accessing various mobile applications, sometimes they want you to give consent in terms of accessing some information about your phone. But, or when you are interacting with a certain application, they can give you a questionnaire to fill some information. Maybe let me say you want to borrow a loan or to submit any other information they are requesting. They can just inform you to complete a questionnaire and so on. So the data here is the questionnaire. Maybe I ask you, how old are you? Are you married? What are your qualifications? So you will be inputting that kind of data. But that's not metadata. Metadata, what I'm interested in is your behavioral kind of data on how you are completing that questionnaire. Like for instance, if I ask Kelvin, how much are you earning? Then Kelvin comes, puts in 100,000 USD, then he erases it, puts again 50,000, puts again maybe 10,000, 1,000, and so on. So I'll be collecting some kind of data that maybe Kelvin is not like metadata. Now I'm interested on the number of attempts that Kelvin was trying to input or to complete that section of a questionnaire. From that, I'll be able to make business decisions, not on the amount that Kelvin has input, but on the metadata, like your behavior. I'm able to pick your behavior data and so on. So that kind of data is mostly semi-structured kind of data and so on. And it is called mostly metadata. So metadata is data on data. Like you are given a questionnaire to complete. Of course, when completing the questionnaire, you are filling data, but we are interested to know how you are navigating through the questionnaire. How many number of attempts? If Kelvin, for instance, and I'm sorry, Kelvin, I'm using your name without consent. I hope I'm allowed. So,
No problem.
But I'm just using as an example. So you see that That's how data has evolved as a result of technology. So you might be thinking that this is the kind of data we are using to make decision, but we go and use other kind of data that maybe you are not aware. Another thing about big data is that it is of variety. As you have seen, it contains numbers, what you call numerical, text. I have explained how you can use the natural language processing to analyze text data. It has images, audio, among many others. So it is of variety. Another thing about the current kind of data is what you call velocity. So velocity is retrieved and computed in real time. Like as you are talking currently, a lot of people are posting on social media, and these companies are collecting this data in real time. We are talking about millions of customers posting every seconds and so on. So you can just imagine the speed at which uh, that kind of data is transmitted. Sorry. Then also it is voluminous, as we can see. We say that this data is a lot, like in terms of volume. For instance, when we are talking about structured big data, let me just pick, for instance, mobile network operators. Mobile network operators have millions of customers. So that data can be structured, yes, but it is voluminous and therefore it is classified as big data. And to tackle such kind of analysis of big data, uh, okay, nowadays I see Excel have been added, like especially structured big data. They have added what you call the Power Query, that you can still handle big data using Excel, structured big data using Excel. But in the past, it had some kind of limitations because of the maximum number of rows that Excel could accommodate that time. But BigQuery has solved that issue. And also, when we are looking at Excel nowadays, in fact, that is the basic data science tool. When we look at Excel nowadays, also, you can connect to a database in real time. So it can be retrieving data and you are getting insights in real time. So that's also another. But when now we are talking about semi-structured and unstructured, Excel cannot analyze that kind of data. And therefore, you need tools like Python, you need tools like R, among many other. Because in most organizations nowadays, this is the data that is available. The challenge has been how to get maybe necessary skills and so on to be able to handle. Before we go to what do you do to data, do we have questions or any point that has not been clear and you need some kind of clarification? Any question that has not been clear? Yes, Hein.
When you're referring to big data, does it have to match all three of those characterizations, or can it be only two of those characterizations to be considered big data?
Okay. So I don't know if I have understood your question, but I think have you said that is it a must that for something to be referred as big data, is it a must that it has these three characteristics? Is that what you meant?
Yes, yes.
No, we have more, but these one are the most common. Yeah, it must have this. These are the most common. One, variety, then velocity and volume. But we have more other that we learn in the big data unit, the practical unit. It is there. But these are the major. For it to be referred as big data, it must have this main characteristics on variety, velocity, and volume. It must be voluminous for it to be called big data. However, in terms of structured big data, mostly um, like there's no clear point that we can decide and say that this is big data. But as I said, what can make you know that this is structured big data mostly is because Excel or ordinary data analysis tools cannot handle it in most cases. Then that becomes big data. And I was giving an example of a telco, telecommunications companies and so on. They have millions of customers, like even 30 million, 50 million, and so on. So you see that kind of data cannot just be processed using an ordinary data analysis tool. Yes, it might be structured, but it can't be processed using any other ordinary data analysis tool. Any other question? Any question or comments in case my speed is also I'm also too fast? You can always let me know. Okay. So in my classes, I do give people some break, 15 minutes, so that in case you came from work and you are unable maybe to settle properly, you can use that time. So I'm giving you guys 15 minutes. You come back at 9:05 East African time, sorry, Nairobi time, which is for our friends Hein and we had another colleague of ours from Rwanda, Mr. Biganiro, I think so. That will be 8. It will be about 8:05 p.m. there. So let us go for a short commercial break. Then we will come and look at what do you do to data. Maybe quickly, I just give a quick recap of what we have covered. We have defined what data science is. That's where we started. Sorry, I don't know why. Let me stop sharing and share again.
Okay.
Okay.
So we have
So
defined what
we
data
have defined what
science
data
is,
science is,
what
and
has come up
what has come
very
up
clearly
very
is that
clearly is that
it is a wider
it
field,
is a wider
a
field, a
multidisciplinary field that
multidisciplinary field that
entails a lot of
entails a lot of
concepts, special
concepts,
machine
special
learning,
machine
data
learning,
analytics,
data
data mining,
analytics,
and so
data
on.
mining, and so on.
We have gone
We have
further
gone
and
further
looked at
and
what
looked at
data,
what data,
and mostly
and
here
mostly
we
here
have
we
looked at
have
the two
looked at the
concepts
two
of data.
concepts of data.
That's the
That's the
traditional data,
traditional data,
and what
and
has
what
come up
has
very
come up
clearly
very
about
clearly
traditional
about
data.
traditional
One
data.
is that it
One
is
is that it is
structured,
structured,
and it can be managed in one computer,
and it
mostly it
can
is
be
in a
managed in
table
one
format,
computer.
and it can contain both
Mostly it
numerical
is in a
or
table format,
text
and
values.
it can contain both numerical
We
or
have
text
gone
values.
further and looked at
We have gone
non-traditional
further
data,
and
or
looked
what we
at
call big
non-traditional
data.
data, or what you call
And one
big
thing
data.
about it
And
is that
one
it's
thing about it
voluminous,
is that it is voluminous,
and it
and
runs across
it runs
various
across
network of
various network of
computers.
computers.
We have
We
also
have
seen that
also seen that
it is made
it
up of
is made up of
variety,
variety,
and
and
like in form of
like in form of
images, audio,
images,
mobile,
audio,
and so
mobile,
on.
and so on.
It
It
travels at a very
travels at
high
a very high
velocity of
velocity
speed.
of speed.
Then
Then also it is
voluminous.
voluminous.
Then
Then
now,
now,
the next
the
thing,
next thing,
having
having
known
known
the two
the two
kinds of
kinds of
data,
data,
traditional
traditional
and
and
non-traditional
non-traditional
data,
data,
I think the
I
next
think the
question
next
is for
question is
us to
for us to
understand, what
understand, what
do you
do
do
you
to
do to
data? Like,
data? Like,
you now
you
have
now
this
have this
data,
data,
both the
both the
traditional
traditional
data
data
and
and
non-traditional data.
non-traditional data.
So I
So
have
I
a
have a
scenario here,
scenario here,
two
two
scenarios.
scenarios.
I don't know
I
why
don't know why
I'm moving
I'm
to the
moving to
next
the
slide,
next
but it
slide,
is
but it is
taking quite
taking
some
quite
time.
some time.
Okay,
Okay.
it is
It
taking
is
quite
taking
some
quite
time
some time to
like it is
like it
taking
is taking
quite some.
quite
I don't
some.
know
I
if
don't
it's
know if
from
it is
my
from
end,
my
but
end, but
the
the
current
current
slide I'm
slide I'm
presenting,
presenting,
it is
it is
a case
a case
study.
study.
So
So
I
so
want
I want
us to give
us to give
ourselves a
ourselves
minute,
a minute,
and we are
and
going to
we are going to
attempt these two
attempt these two
scenarios
scenarios to
to know
know
the difference
the
between
difference
the two
between the two
scenarios.
scenarios.
So
So the case
or the
study, or the
item
item
here
here
is that
is that
imagine
imagine we
we
have
have the two
the two
scenarios below,
scenarios below,
and this
and
one,
this
you
one,
are an
you are an
analyst for a
analyst for
large
a large
company,
company,
and your
and your
manager
manager
approaches you
approaches
with
you
a
with the
request. As
request,
below,
as
we have
below we
two
have two
scenarios.
scenarios.
So
So
you are
you are
an
an
analyst,
analyst, a
data
data
analyst
analyst
in
in
a large
a large
company.
company.
Then
Then
you
you
have your
have your
manager
manager
is able
is
to
able to
approach you with
approach you
two
with two
scenarios.
scenarios.
The
The
first
first
scenario
scenario
is that
is that
you
you
need to
need to
consider
consider
client
client
satisfaction
satisfaction
in the
in the
next
next
quarter,
quarter,
so
so
that you
that
can
you can
predict
predict
churn
churn
rate. And
rate.
when we
And
are
when you
talking
are
about
talking about
churn rate,
churn rate,
is the
is the
rate
rate at which customers are dropping or are stopping to use a certain product or service. That's what you call churn rate.
so
So
the
the
first
first
scenario I want
scenario, I
you
want you guys to
internalize
internalize
the
the
two
two
scenarios
scenarios
very
very
well.
well.
The
The
first one
first
is
one
that
is
you
that you
need to
need to
consider
consider
client
client
satisfaction
satisfaction
in the
in the
next
next
quarter,
quarter,
so we
so we
can
can
predict
predict
churn
churn
rate
rate
and
and
oversee the
oversee the
process
process
and
and
come up
come
with
up with
some
some
numbers.
numbers.
So you
So you
need to
need to
consider
consider
client
client
satisfaction
satisfaction
in the
in the
next
next
quarter,
quarter,
because one
because
of
one
the
of the
causes of
causes of
churn rate
churn rate
maybe
may be
customers are
customers
not
are not
satisfied with
satisfied
the
with the
products or
product or
services a
services a
certain
certain company or
organization is
organization is
offering.
offering.
So you
So
want
you
to
want to
predict
predict
churn
churn
rate
rate
and
and
oversee the
oversee the
process and
process
come
and
up
come
with
up with
some
some
numbers.
numbers.
The
The
second
second
scenario,
scenario,
you
you
have
have
an
an
enormous
enormous
amount of
amount of
customer
customer
data
data
from the
from the
previous
previous
quarter.
quarter. Then you have been told to oversee the analysis and deliver an approximation of churn rates for the next quarter. The second scenario is that you have an enormous amount of customer data from the previous quarter. You are told to oversee the analysis and deliver an approximation of churn rates for the next quarter. So, based on these two scenarios, you can attempt to explain to us the difference between the two scenarios highlighted. Any attempt? Yes, Hein.
If I would guess, I would say the first scenario looks at reviewing the client satisfaction, as it says, so looking at reviews and surveys and data on how they found your product or service that you're delivering. While the second one can look at a much larger data set, such as, financial information and a larger set of variables on what might be affecting the churn rate. Well, the first one is only assessing satisfaction numbers.
Okay, thank you. I've said the first one, you are looking at assessing the satisfaction. And the second one, mostly you're looking at having a lot of data and trying to oversee what will happen. Thank you for that. That's a very good attempt. Any other person with a different opinion? Yes, Caleb. Sorry for that. Caleb, yes. I was speaking on mute. Sorry for that.
The first scenario is a situation where the numbers for the satisfaction are not there. So the idea is to try and find out how probably the customers will behave, and in the process, either scientifically or intuitively, they come up with the numbers so that the prediction is able to be done. While the second one, then the decisioning is based on existing numbers that are historical, that then will be worked on to arrive or find out the channel themselves. That's what I'm thinking.
Yeah, thank you so much, Caleb, also for that. It is very clear. The first scenario, we don't have data. We don't have existing data, but you have been told to come up with the client satisfaction in the next quarter so you can predict the churn rate and oversee the process to come up with those numbers. So it is clear that you don't have numbers, you don't have data, and what your manager wants is for you to come up with a solution on how you are going to tackle it. When we are looking at the second scenario, this data already exists in the company. You are only required to oversee the analysis and deliver an approximation of the churn rate for the next quarter. Thank you so much, Caleb and Hein, for your contributions. That one leads me to another question. Because those two scenarios have brought up something in my mind. So this one, I'm just picking someone directly. Naomi, if you can hear me, that is Musuva. What do you think as a data scientist or a data analyst, based on these two scenarios, what do you think your like as a data scientist or a data analyst, what kind of a person are you supposed to be in that organization?
Well, thank you, Xavier. I can hear you. What kind of a person am I supposed to be? Well, I'll probably think at first hand, I'd say both, but most importantly, second scenario where you're looking at actual data to help them make decisions. But I guess also some element you need to have the intuition of prediction. So yeah.
Okay, thank you so much, Naomi. But I don't know if my question is ambiguous, but I'm looking from a management point of view. Like when we are hiring you as a data scientist, there's something, these two scenarios have brought one of the aspect that I think, based on my own view, a data scientist or a data analyst should have. Yes, Mr. Big
Okay.
Aniro, sorry.
No, sorry. I thought you were still asking me. Anyway, I would have still said the
I
second
think
scenario, being able to maneuver the data that the company has.
Okay, thank you, Naomi. Still a good attempt, but let us give first of all Mr. Biganiro an attempt.
I think the first one will be data scientist because he need to train the data, and the second one will be the data analyst.
Thank you, but I'm looking at a personal attribute, more of a personal attribute than I think maybe my question has been ambiguous, but I'm looking at a personal attribute. Yes, Hein?
I would say for the first scenario, you need someone that's intuitive. And for the second one, you need someone that's analytical.
Thank you so much. Yeah, I can pick those two. But let us hear from George also. George, what do you have for us? George, I saw your hand is up, was up.
Yeah, thank you, Xavier. I think another maybe attribute that I would say would be required is, for instance, an understanding of statistics so that you are able to understand what is currently happening. Then from this, you can be able to make a prediction. I'd also maybe add and say that you also need to understand the business needs of the organization you're working with. For instance, if you're talking about churn rate, and is looking at the rates at which customers are dropping off, you may just need to understand more about the products on offer so that when you're giving your output, you're able to give a detail, maybe not just say, overall, we are at 5%, maybe we'd say for product A, we had this number of customers showing an interest, this number dropped off for product B and so on. Thank you, and back to you.
Okay, thank you so much all for the contributions. But one thing that has come up very clear, first of all, in whatever you are doing, you need to understand the business problem. Number one, irrespective of how simple or complex your analysis will be. The second attribute that I have seen on my side also, maybe to add on what Hein, George, and I think Naum have mentioned, is you must be a problem solver. Like, you see the first scenario, you don't have data. So it means that you must have a deep understanding. And as George has said, where are you going to get this data from? You must be having that knowledge to be able to look for that data so that you are able to deliver on your KPIs and so on. But you see that in the second scenario, you already have the data and so on. I think that is okay. Then I want just to now introduce something. So maybe before that, Basically, whatever we have learned here, another thing that we have picked up here is that in an organization, you can have readily available data. At the same time, you can have some kind of data that you have to look from other sources and so on. So this is something that we have picked from this concept here. So after that now, I just want to introduce this section, then we will continue tomorrow. What you call pre-processing. What you call pre-processing. So regardless of whether a data scientist is given any kind of collected data, as we have seen, or if you go, you have to go through that a process of gathering data and so on in raw format. As you have seen, the first scenario, it means that guy had to go and collect some kind of data, maybe in form of a questionnaire and so on. The data that comes in form of surveys or any other automatic data collection in your organization is never ready for analysis. So all this data, we call it raw data. And this data needs to be converted into a form that is more understandable and useful for processing. So all this process of you are trying to convert. I know when you go to machine learning units, you will learn a lot of data pre-processing because it is part of the machine learning process. You have to pre-process your data first. And any other kind of analysis. Even for instance, you are having structured data and so on in your organization, you must do some kind of pre-processing. And even you can do a very simple pre-processing. Maybe you are having a lot of columns, a lot of rows, and so on. So you have to remove those that you don't need and remain only with the kind of information that you need. That process is called data pre-processing. Like you are trying to make your raw data into a form that can easily be utilized or can easily be consumed by other people, like your colleagues in other organizations. And most of the people who are doing data pre-processing, especially when you are dealing with large amounts of data, big data and so on. I don't know if you have ever heard of what you call a data engineer. Data engineers mostly do batch pre-processing of data so that any other person from other departments are able to easily work with this data. But as I said initially when we started, it depends with the organization. That's why you have to, when you cover, for instance, the certified data scientist a curriculum, you will be very confident to cut across all those departments. You can be able to pre-process data, visualize, analyze, build machine learning algorithms, and even deploy them, and so on. So in organizations that have deeper pockets, they can hire just someone who does pre-processing, then another person, or people pick from there. So I don't want to go further. We will start from here tomorrow. I like my classes when they are a bit brief so that guys can understand. But before we end, I just want to pick Miss Mary to give us a recap of what we have learned today. Then after that, we have questions. After questions, I have the notes in both PDF. I'll share by email the entire notes. Then the recordings I'll be sharing before, you will be getting them as soon as possible so that you can even review tomorrow before we go to our next session. So, Miss Mary, just give us a recap of what we have learned today. Anything that you can recall. It is not a must you follow the like. It is not a must you follow from first topic and so on, but anything that you can recall.
I'm not sure whether you can hear me.
You are not audible enough.
Okay, let me type. My mic is not the best.
Yes, come up again.
Let me type. My mic is not
Yes.
the best.
You are typing.
Yes, my mic is not the best. Let me type.
Okay. No worries. Maybe as you are typing, I can pick another person, Kennedy or Kinda. If you're in a position to speak, you can assist us to give us a recap from your end also, what you have covered.
Yes, Xavier, hope you can hear me.
Yes, I can.
Okay. From basically what I've learned from today's class is the types of data that we have, where we've talked about traditional data, which is a structured data that is majorly stored in the computer system. Then also we've also looked at the another data which is I don't know, it's large data, which we generate from several platforms, and mostly they come as structured, semi-structured, and unstructured data, especially data that we gather from social media. So that is what I've learned from today.
Okay, thank you so much for that trial. I want also to give an opportunity to, I think, Belinda Ndagano, an attempt. Anything that you have learned today?
Hello everyone. So for me, what I've really picked is on the last two slides where you talked about the raw data, where someone has no data, and then where someone has raw data. So from the beginning, for the one who has no data, he has to go through a process which is data collection. After data collection, he does his analysis, then gives his findings. Then from the one who has raw data, he has to go through a process which is pre-processing. In I think simpler terms, it would be like cleaning the data, because now he has been given a bunch of data and he has to turn it down. Okay, tweak it to the point of it brings out what he actually wants to give to his managers or whoever is asking for the churn rate, I would say. Yeah, so that's what I picked from this lesson today.
Okay, thank you so much, Belinda. Let me go to Hein. Hein, you can tell us what you have learned today.
I've been taking notes, but I've learned obviously there's the differences between traditional and big data, where traditional data would fit in a single server or in smaller capacity, and is typically structured data that you would find in a SQL or small database, while big data would live across multiple servers and has the characteristics of variety, velocity, and volume.
Thank you so much, Hein. Mr. Biganiro, I don't know how I can pronounce your first name. Maybe you can assist me. Okay.
Okay. Um, I learn about the introduction data science, the definition, and also I learn about classification of type of data, structured and unstructured data, the differences. I think that's the main one.
Okay, thank you so much. Let me pick the last two people. Benson, are you in a position to speak? That's Benson Dugo.
Yes. So for me, I've learned about the difference between traditional data and big data, where we have seen that traditional data, mostly it is structured, stored in database. It can be managed by one PC. Mostly it contains text and numerical. Whereas for big data, it is characterized by the 3 V's, that is variety, velocity, and volume. Yeah, I think that is the
Okay.
bit that can recall.
Okay, thank you so much. Maybe I can give the last opportunity to Wangui Kanyi, then we close there. Wangui, in case you're in a position to speak. Okay, maybe Kelvin Karani, you can come in and give us what you have learned.
So I think most of the areas have been mentioned, but one thing that I've been able to pick out clearly is on the case scenario that has been presented. Number one, on how to understand the business problem and also how to come up with a solution, and being able to identify where cases where you have available data that you can use to do analysis and come up with a decision.
Okay, thank you so much, Kelvin. Then maybe go. I saw a hand that was up. Jesse, yes, Jesse.
Mr.
That's
Savia,
Jason
help me
Baria.
understand yes. The last slide, help me understand the preliminary data. There's something I didn't understand about the preliminary data and the pre-processing.
Okay.
Kindly explain it.
Okay, I'm there. So when I'm talking about preliminary data, I can call it like some kind of original data, like a preliminary is just an English term, because the main reason I call it preliminary, we call it preliminary data, is that this is data that is not ready, and therefore it must be pre-processed first. And pre-processing is not analysis. I want you guys also to differentiate between the two. To pre-process data does not mean you are analyzing it, but you are just trying to make it ready for other people to use easily. And that's what you call pre-processing. So that data that you are doing, that pre-processing and so on, we can call it preliminary data. Then after you pre-process now, it can be shared with various people in other departments so that they can easily consume. Because remember, in an organization, for instance, we have the business intelligence department and other departments that might need this data to analyze themselves. So if it is so technical and they don't have these skills, it means that they'll struggle. That's why mostly we do that pre-processing. I don't know, Jesse, if that is a bit clear.
Yeah, thank you. It's clear.
Okay. And then Kennedy, I see your hand is up.
Yes, I just wanted to ask a question, not pertaining to today's class, but needed from your
Yes.
point of view. Now that we'll be dealing with issues of data and maybe systems, coding, and all that, would you advise in the type of maybe if someone wanted to upgrade their laptop or purchase a new one in terms of specifications?
Yeah, I'll confirm with our CTO, that's the technical guy. But nowadays, it is not a must you code in your desktop. As I think yesterday I mentioned that in case you are having a slow laptop, we have the cloud-based kind of platforms whereby you just get email address, sorry, your account, and you code from there, like you. It is a cloud-based platform, development environment, and so on. But Kennedy, you might be speaking on mute. Can someone hear me, please?
Yeah, I've gotten it, Rob, but now, yes, we are getting you.
Yeah, okay.
Yeah, we've gotten you. Thank you.
Yeah, that shouldn't is slow, but any other question before we close? Yes, Naomi.
Yeah, sorry, just to take you back. Scenarios, the one for the predictive. What exactly did you want us? Sorry, I think I missed that part. What exactly did you want us to draw out of the two scenarios by your question?
The two scenarios. The first one showed that you don't like because when you, no data, then raw data. Like the first scenario. In the second scenario, there was already existing data that was there in the organization. So the main objective but it doesn't mean in both cases that you have ready data. In some cases, it means you have to look for that data. In another case, it means you might be lucky to find the data. So that's what we were looking at with regards to the two scenarios. Is that clear, Naomi?
Yes, that's clear. It's just that.
So when we went on the attributes, first of all, one thing is that came out is that you need to have business understanding of the business problem. The second one also we looked at problem solving skills. Like the first case, you don't have data, and it means that you need to find a way. How are you going to get this data? Of course, you might have skills maybe to conduct some kind of questionnaire, to research and find some, or you can do even web scraping. Nowadays, you'll be trained on how you can gather data from various online platforms and so on. So you need problem solving skills because you don't have that ready data, so it means that you need to be able to find a way in which you can able to perform that specific task that you have been given. Is that clear, Naomi?
Yes, that's perfect. Thank you.
Okay, thank you.
I have a question. I don't know if yesterday you have answered it. It's regarding this certification. So
Yes.
we are doing both data science or business analytics. So I was not there yesterday, and I want to be
Okay,
clear.
thank you. So business analytics is a subset of data science, or I can call it a child, like all the units that are covered in business analytics are covered in data science. That's why it is a combined class, but not all the units of data science are covered in business analytics. So at some point, if you look at, I shared the two curriculum. The business analytics, you have about 11 units, and certified data scientists, you have 16. So the certified business analytics guys will exit at some point and proceed to exams. But most of the units you'll be sharing together.
Okay, thank you.
Okay. Any other question? So I think we can end here. Thank you for attending today's session. I'm going to share the PDF of the entire notes for this specific course, and other materials I'll share after we are done with the unit, including the CAT, the continuous assessment test. But the recording for today's class, you'll be getting, in case you don't sleep early, you'll be getting it. For those who will sleep early, you will access it tomorrow in the morning. Thank you all. Have a